This video I'm going to talk about molar volume. So first of all, molar volume, we can find some information from the periodic table. Okay, so I'm going to use blue pen. Now, molar volume, there's information which is right here. Right, so that's the two information we can get. So first of all, molar volume of ideal gas law at STP is 22.4 liter per mole. Now, what does that mean by molar volume? Molar volume of a gas is the volume of 1 mole of ideal gas at the STP. Okay, so what does that mean by STP? STP is the standard temperature and pressure. Okay, standard temperature and pressure meaning the pressure is 1 atm, temperature is 273 K or 0 degrees Celsius, which is actually the absolute zero. Okay, it's the absolute zero. All right, and the N is 1 mole. So standard temperature and pressure is the pressure 1081 atm. The temperature is either 273 K or 0 degrees Celsius, and then also 1 mole. So again, this information, you can find it, the STP, you can find it from the periodic table, 1 atm or 101.3 kilopascal. And then just 273 K or 0 degrees Celsius. And the molar volume, meaning the mole is 1 mole. So in this situation, how many liter per 1 mole is 22.4 liter? So the molar volume is 22.4 liter per mole. But this is only at STP condition. So if your pressure is not 1, your temperature is not 273 K, then you cannot use this number. Okay, you can only use this number, 22.4 liter per mole, when you have STP, when you're at that pressure, at that temperature. Otherwise, you cannot use this number. Now, what is the good thing about using this number? Okay, and the good thing is, let's check this out. Now, the good thing is, let's say if you have the ideal gas, okay, ideal gas law, PV equals nRT, all right? Now, if you can have the pressure is 1 atm, temperature is 273, okay? If you, let's say I have 4.5 mole, okay? Let's say, I'm looking for volume, for example, I'm looking for volume, all right? And then if you have, my N is 4.5 mole, given my N is 4.5 mole, and then I have my R, I'm using the R constant, is 0.0821, and then my temperature is 273, and my pressure is 1, and I'm looking for my volume, right? So let's say, given this question, right, 4.5 mole of hydrogen equals to how many liter? So, oh, okay, I tell you that it's STP. That means, oh, my pressure is 1, my temperature is 273. So I substitute all fitting information. So I'm looking for my volume. So my mole is 4.5 mole, my R is 0.0821, temperature is 273, and my pressure is 1. If I substitute all the information, okay, I will get this answer, 100.8. But instead of substitute R, the 273 and 1, I'm going to put 22.4. Why? It's because if you actually take this number, 0.0821 times 273 over 1 is actually roughly about 22.4. Okay, so if I take 4.5 times 22.4, I will still get the same answer, 100.8. So instead of substitute R, temperature, and pressure 1, if I realize that this is STP, I don't need to do that first part. I can just make it 4.5 times 22.4. Then I will still get the same answer. Okay, I will still get the same answer. So you can you don't have to do so many substitution. I can just, when I recognize that is STP, I can just use 22.4 instead of using R constant, the 273 temperature, and the 1 atm. That's what it is. Okay. The step to do this molar volume has 3 steps. Number 1, you have to write the strategy. Just like I have to recognize that, oh, this is Boyle's law, this is Charles' law, this is Gay-Lussac law. Oh, why? Because whatever temperature change, whatever number constant, you have to give the reason part. So then the reason part for the molar volume is you just write down one sentence. Molar volume at STP is 22.4 liter per 1 mole. Okay, so you can basically you can just copy this. A molar volume at STP is 22.4 per liter. I'm sorry, 22.4 liter per mole. Just write this sentence to replace it, like just kind of like oh, because this pressure is constant, that change, that's why it's whatever law. So step 1, you have to tell me the reason thing. And step 2, you write down your map, strategy map. So if I was given mole, you're looking for liter. Like if you change back and forth between mole and liter, you have to use molar volume. Right? Very easy to imagine. Molar volume, that means I will have mole and liter because volume is liter. So if you go between, like if you change back and forth between mole and liter, I'm using molar volume. And if there's a question, I go from gram to liter or back and forth. I give you gram, you're looking for liter. I give you liter, you're looking for gram. Again, there's no one single step to go from gram to liter. So what must be in the middle? Just like when you do stoichiometry, what must be in the middle will be mole. So you have to write the strategy from gram to mole, from mole to liter. And remember, if you go from gram to mole, we use molecular mass. Remember that, mm, right? Because molecular mass, so mm. And then from mole to liter, we use mv. There's another kind of question if I go between particles or molecules, right? So particles and molecules or atoms, right? Particle molecule are the same thing. So from particles go to liter, again, there's no one single conversion. I have to use mole. So you will use Avogadro number first because Avogadro number has the definition of mole and particle. Remember the Avogadro number here? Right, I have the mole and particle, molecules, atoms. Okay, so if you go between particle and mole, I'm using Avogadro number, and if I go between mole and liter, I'm using MV. And then step 3, you're gonna do Superman and the unit cancellation. So it's involves 3 steps. So let me just do one question at a time. Okay, so make sure that you have to recognize, right, at the STP, these are the conditions. Okay, so make sure that you recognize STP is these conditions, and you don't have to memorize this number because right, molar volume is 22.4 liter, because you don't have to memorize that because it's in the what's that called, in the periodic table. Okay, so again, the step 1 here will be the method. Okay, step 2 will be the strategy. Okay, all right, and again, the particles here I can use molecules or atoms. Okay, and there is a one thing that I want to point out is, do you remember diatomic gas? Right? Because sometimes the question just give you the name. So diatomic gas, all right, you have to remember there are 5, let's see. So I say gas. Now we have 7 diatomic, but 5 of them are gas. Only 5, right? So which 5? Is H2, N2, O2, F2, Cl2. They are 5 diatomic gas. What about bromine, Br2 and I2? They are not gas. Here we're talking about gas. So we don't need to worry about those things. We just need to worry about these 5. So when you see hydrogen, don't just give me H. You have to give me diatomic. Right? So the first, you have to read the question. Did the question say the following gases is at STP? It's very important that you either saw, oh, STP, or they say, oh, the pressure is 1, the temperature is 273 K or 0 degrees Celsius. You have to see this information in order to use molar volume. If you don't see this information, you can't use the molar volume. Right? So my first kind of question is between mole and liter. So I'm gonna just, there's an example here, okay, there's an example here. So from mole to liter, I'm using MV. So if I give you 4.5 mole of hydrogen, okay, so you're gonna set up Superman of 4.5 mole hydrogen, and then I say, oh, you use 22.4 liter per mole, that means 22.4 liter per 1 mole. So, oh, which one's gonna be on the bottom? 1 mole will be on the bottom. 22.4 liter will be on the top. Why? Because the mole will be cancelled. All right, and then you round it to 2 places. Okay, so again, you have, let me write it on here. So you gotta write, let's see, you gotta write 22.4 liter per 1 mole. Okay, per 1 mole. Right, so let me just do number, let us see here. 58.91 liter of methane gas equal how many mole? Okay, so my first step is I'm gonna write down molar volume at STP equals 22.4 liter per mole. Right, just write this sentence. That would be kind of like, you know, same thing as oh, I'm rating this is what kind of gas law, why, something like that. And number 2, I'm going to set up, write down the map is I start from liter and I have to go through the mole, so I'm using molar volume. And then step 3, I can set up Superman 58.91 liter CH4. And then write like this. Okay, so I have liter on the bottom. So what do I need to put on the bottom? 22.4 liter CH4. Okay, but again, make sure you write down what compound it is. And then 1 mole CH4 on the top. So there are 2 things you need to cancel, right? You need to cancel the liter. You also need to cancel the compound, whatever the gas, CH4. And then after that, you do your math. You will find out you get 2.6299107114, and will equal to 2.63, and my unit is mole, and the gas is CH4. Okay. All right, now next kind of question is change between gram and liter. So the example here is you're giving gram, you're looking for liter. So again, you write down molar volume at STP equals 22.4 liter per mole. And then you write the strategy from gram to mole, from mole to liter. And then you also set up Superman. In the middle, the first Superman, I'm using MM. Second Superman, I'm using MV. That means you have to be careful that I have to write out the correct formula of the gas, because now you're looking for MM. If you just write, for example, if you just write Cl, or if you just write helium, the MM is 4, right? Because helium is not diatomic. But what if the chlorine gas? You have to be careful. Oh, chlorine is diatomic. Then you have to write down. Be careful with the MM. Okay. Now here, I don't need you to show me how to find the MM. Just write down the correct MM is fine, right? So I'm giving 88.12 liter of chlorine gas, and I'm looking for my gram. So the first sentence I'm gonna write is molar volume at STP equals 22.4 liter per mole. Okay, and then step 2, I'm going to write out my strategy. I was given liter. And again, I can't go through the gram directly. I was given liter, and I'm looking for gram. I have to go through mole first, and then I will go to gram. So from liter to mole, I'm using molar volume, all right, molar volume. And then from mole to gram, I'm using molecular mass, mm. All right, so then step 3, I'm going to write out. I have 88.12 liter. Now here, chlorine, don't just give me Cl, it's Cl2. It's very difficult for me to draw the line like that, okay? So first, MV. MV is 22.4. Now I have liter on the bottom, so I put 22.4 liter Cl2 on the bottom, and then 1 mole Cl2 on top. Right? So then now my L and L cancel. And then I will jump to mm. Now the mm for Cl2 is 70.90. Okay, the mm for Cl2, like 35.45 times 2, is 70.90. So that is gram per mole. So here I have 1 mole. That means 1 mole will be on the bottom, and then my gram will be on the top. 70.90 gram Cl2. Okay, so this number is mm. Right, this number is mm. Right, so I need to cancel my mole and mole. Right, so after that you will only have gram left over. That's what I'm looking for. And then your math, I will get 278.9155357. 357. Okay, so 278.9155357, and I will equal to 278.92 gram Cl2. So this is my answer. Okay, now here you just need to be careful if it's diatomic gas, that's all. Otherwise, really straightforward. Okay, now the last page, okay, is talking about particles to liter. So again, the map is particle to mole to liter, back and forth, okay? And we're using Avogadro number. So the example was given to you from particle to liter, right? And do the same thing. And your Avogadro number is 6.02 times 10 to the power 23rd. So let's just do one question. Is 134.5 liter of hydrogen gas to how many molecules? So I'm going to write down molar volume at STP is 22.4 liter per mole. Okay, so that's step 1. Now step 2, I was given liter to molecules. So I can't go directly. That means the mole must be in the middle. And then I will go to molecules. And molecules, particles, the same thing. So from liter to mole, I'm using MV, molar volume. And then from mole to molecule, I'm using Avogadro number. So step 3, we set up Superman. So 134.50 liter hydrogen gas is H2. All right, it's diatomic. So, right, so the first one I'm using MV, right, 22.4 liter per mole. So 22.4 liter H2 on the bottom, and then 1 mole H2 on the top. Okay, so I'm going to cancel my liter. All right, and then the second number, I'm using Avogadro number, 6.02 times 10 to the power 23rd molecules per mole. So I will put 1 mole H2 on the bottom, and then I will put the Avogadro number on the top. 6.02 times 10 to the 23rd molecules H2. So this time I'm cancel my mole and mole. And then you do the math regularly, and you will find out the answer is 36.146875 times 10 to the power 23rd. Alright, so again, I'm not happy with this because it is the scientific notation is still good, right? So I'm gonna bring this number to here. Right, so I'm not happy because scientific notation no good. So I'm gonna make it 3.6146875 times 10 to the power 1 times 10 to the power 23. Okay, because I'm fixing this part. And then I round it to 2 places. I will get 3.61 times 10 to the power, you add the exponent, will be 24 molecules H2. So that's the answer. Right? The bottom, the word problem, just tell you, all right, that's a hint, okay? A sample ammonia gas NH3 contain 0.05 mole. What volume is the liter at 180 m and 273 K? Now, the question did not tell you the word STP, but you recognize that STP is at 1080 m, T is 273 K. Again, this kind of information, you can find it from the periodic table, 180 m, 273 K. So even though the question did not say the word STP, you recognize that this is STP. And then you can use molar volume. All right, you got to do the same thing. So with the question, sometimes they say STP, sometimes they tell you the ATM, sometimes they give you like degrees Celsius or Kelvin, 273 K. You have to recognize that, oh, this is STP, label it. Then you can use molar volume. Otherwise, you cannot use it. Right? So this is for the molar volume worksheet.